So in this video, I'm going to talk about how to interpret your output for your t-test and your Mann Whitney U test. And this is all related to chapter 5, problem number 1. And remember, in this example, they are asking, is there a difference between an herbal formula versus a placebo in number of hours that you have slept? And so if you think about what the hypothesis might be, that the researchers may have made. This is why sort of, a hypothesis and what we learned about those is important, is that a hypothesis for this study might be that those who took the formula have sleep longer than those who took the placebo, or get more hours of sleep than those who took the placebo. So you've ran through the test, you have this output, and now you're looking at the screen thinking, okay, how do I interpret whether or not there was a difference between the placebo and the formula? So I'm going to walk you through this output. We're just going to start with the t-test to start with. So for the t-test, you can see on our output, we have hours of sleep is our dependent variable, and then we have our independent variable is whether they took a placebo or a formula. So this column N is how many people were in the placebo group and how many were in the formula group. So you can see there were 7 in the placebo, 6 in the formula, and so 13 total. Here you have the mean and standard deviation. So the mean for placebo was 4.40 hours of sleep, with a standard deviation of plus or minus 1.44 if we're rounding. For the formula group, our mean was 4.90 hours of sleep, plus or minus 0.87. And so if I was asking you for descriptives, or if you need to report the means, you would write out that those who took the placebo had a 4.40 plus or minus 1.44 hours of sleep. The group that took the formula had 4.9 plus or minus 0.87 hours of sleep. So these are all of our descriptives where you can find the mean, the standard deviation. What we really want to know is in our grouping, was it statistically significant, or did this sort of just happen by chance that, as you can see, the formula group got 4.9 hours on average, where the placebo group got 4.4. But what we want to know is that statistically significant, or was that just based on our samples, kind of a random sample, and sort of random that it happened that the formula group slept longer? So we need to go down here to our independent samples t-test. So this is the test that you have run. And in reading this, this portion here, this is the portion that you're going to look at to determine if there is a difference between the placebo and the formula group. So what you need to decide first is which column, or which row you're going to read. And so there are 2 rows to choose from: equal variance is assumed and equal variance is not assumed. So how we decide which one to use. We're going to use this Levene's test for equality of variances. And so this is automatically calculated in this output. And you can see that the Levene's test for this problem, your significance value, this SIG is your significance value is 0.381. And so you're going to use this number to determine which row you're going to read from the rest. And so if this value is less than or equal to 0.05, because we've set it at 95% alpha level, so the significance level is 0.05. If it's less than 0.05, then equal variances are not assumed, because this would say the groups are different. So equal variances would be not assumed. If it is greater than 0.05, then there is no difference in the groups, and we would say that equal variances are assumed. And so just remember that this isn't the significance for, is there a difference between the placebo and the formula? We're just looking at, are these groups different or are they the same in themselves? And so because this is greater than 0.05, that means that there is no difference. So we're going to go with the second column, equal variances not assumed, or the second row, sorry. So the second row. So we are going, in order to find our answer, we are going to come across this row, and under significance, you can see there's a one-sided or a two-sided p-value. So these are your p-values right here. If your hypothesis was one-sided, then you would use this number. But if your hypothesis was two-sided, meaning you just wanted to say there was a difference between the groups, you didn't say that formula was greater, let's say. So depending on what your hypothesis was, would depend on which one-sided or two-sided you would use. So let's say we decided our hypothesis was we just thought there would be a difference between the groups. Then we would use that p equals 0.46 if we're rounding, so 0.46. And so you would decide if this difference is significant by determining whether it's less than or greater than 0.05. And so this is greater than 0.05. And so therefore there is no difference between the groups. If our hypothesis was one-sided and we said something like the formula group has greater hours of sleep, we would use this one-sided column. And so that would be 0.23. Both of these are still greater than 0.05. And so our difference is not significant. So even though the formula group, the average was 4.9 hours of sleep, which was more than the placebo group, it is not statistically significant because our p-value is greater than 0.05. So that's your t-test. And then I've also done the non-parametric test, which I'm going to scroll down here. So it just is on the same output. So the same data set. The non-parametric test looks a little bit different. And so what you're going to look at here is basically this gives you your null hypothesis. It tells you what test you've ran, and then it's giving you the significance. And so it'll give you the significance and then tell you that you would retain the null. So in this table kind of gives you everything you need here, but you can also look at this test summary and it will give you your significance for the two-sided test down here, 0.366. And so because this number 0.366 is greater than 0.05, there is not a statistically significant difference. If it was less than 0.05, it would be a significant difference. And so there's also some other graphs and things that come out with this that can kind of show you your data in different ways. But just in order to interpret this, this is really the only section that you need for your Mann Whitney U test. So what we found with both of these tests is that there is no statistically significant difference between the group that took the placebo versus the group that took the formula and how many hours of sleep that they received.